Hello everybody, we did our YouTube project on magnetism, which we recently learned about in class. This project was brought to you by Aisha, Jancy, and Olivia. Hope you enjoy.
So what is magnetism? Well, magnetism is a physical phenomenon produced by the motion of electric charges, resulting in attractive and repulsive forces between two objects. Similar poles repel while opposites attract. This is because the pulling force of attraction you feel as magnets stick to each other is the north pole of a magnet drawing itself to the south pole of another magnet. Identical poles will repel or push away, so when it comes to magnets, opposites really do attract.
Magnetism works because of two things: the spin of the electron and the revolution of the electron around the nucleus of an atom. The spin of the electron is the most important part. If two electrons spin in opposite directions, the magnetic charge will cancel out and the object will lose its magnetic properties. This is what happens to most of the items on Earth because they are not magnetic, which means their electrons are spinning in opposite directions. However, if the electrons spin in the same direction, then the object has a stronger magnetic charge. You can think of it kind of like the Earth orbiting around the sun. The Earth spins around to create the day and night, but it also orbits around the sun.
Laws and concepts. Unlike poles attract, while like poles repel. A magnet has a magnetic field around it. The closer the magnet, the more force will be exerted. Newton's third law. For every action, there is an equal and opposite reaction. If a bar magnet is cut into two pieces, the pieces become individual magnets with opposite poles. Ways to damage a magnet. By heating, dropping, or hammering. It breaks down the magnetism in the magnet. Laws of magnetism. A longer bar magnet will retain its magnetism longer and have a stronger magnetism compared to a shorter bar magnet. And now for the experiments.
Two magnets are used here to show the properties of magnets. You can see that when one magnet is outside the magnetic field of the other, it does not attract. But when it is close enough to the other magnet, it automatically attracts to the other magnet. Likewise, the opposite poles of the magnet attract, while the similar ones do not. You can see that the magnet falls down and automatically switches over so that the opposite poles attract. The first experiment we conducted is a common experiment used to visualize the magnetic field surrounding a magnet. For this experiment, you will need iron fillings, since iron is a magnetic material, and these are small shavings of iron that will show you exactly where the magnetic field lines are. You will also need a sheet of paper to put over the magnet so that you are clearly able to see the lines and the fillings don't end up sticking to the magnet. Finally, you will need a bar magnet with two poles. Here we can see that the north pole is blue and that the south pole is red. So the first thing that you need to do is place your sheet of paper over the bar magnet. Once you have done that, you need to take your iron filling bottle, open the lid, and sprinkle the iron fillings onto the sheet of paper, as we can see here. The fillings will start to line up, but to help make the lines clearer, you can gently tap the piece of paper. This will help the fillings shift into the right place. After you keep tapping for a little bit, you will see the fillings shift even more. And then eventually they will line up into the magnetic fields that you will be able to see. Right now the magnetic field lines are starting to form. Finally, you can see that the lines are beginning in the north pole of the magnet and ending in the south pole of the magnet, just like we learned in class. The field lines outside the magnet are supposed to start in the north pole and end in the south pole, and inside the magnet they will be going from the south pole to the north pole. I also tried conducting this experiment at home with a circular magnet. I placed the magnet onto a napkin and then placed a sheet of paper over the magnet. Then I took my iron fillings jar and sprinkled it over all around and tried to do it evenly so that the magnetic field lines would be able to show. After sprinkling the iron fillings down onto the piece of paper, you can see that I tapped the paper gently and tried to spread out the magnetic iron fillings so that they would be able to show the magnetic field lines a little more clearly. The results weren't as clear as I had hoped, just like in the animation that I created, but they produced a pretty cool pattern, as you will see in the picture right after the video. In conclusion, we used our experiment on magnetism to show the magnetic field lines of a typical magnet, as well as the properties of a magnet. These laws of magnets support Newton's third law, which is that for every action there is an equal and opposite reaction. Thank you so much for listening.